Greetings, welcome on my channel. My name is Constantine Yachnytskyi, and in this video I'm going to discuss my point of view about Rust and Go or Golang, as far as I prefer. I'm going to touch it from my own perspective as a software developer, and I'm going to try to look at this from a business perspective, business point of view, how they see. So let's start. Basically, in a nutshell, Go is much easier, simpler than Rust. It's very minimalistic. It has a kind of C philosophy. I mean that if you need something, just write it on your own. Sure, there are some libraries, frameworks and so on, but it's much less compared with JavaScript, for example, I mean Node.js or Java or Python, for example, generally mainstream languages. So if you use Go, you need to be ready that you may need to implement a lot of things on your own, because you may run into problems that either libraries you need don't exist, or even if they exist, they're not good enough, and, like, for example, not performant enough, don't cover all of your needs, and so on. So just to keep it in mind. But generally it's the easiest language ever I've ever known. It's too minimalistic. It has its own pros and cons. What's good about Go that yes, it's really easy to learn this language and start working with it. There are not a lot of keywords, generally no syntax sugar, nothing like that. But there is also a downside about it. The downside is that there is more boilerplate generally compared again with the other mainstream languages, such as, for example, Rust, JavaScript, Python, Java, and so on. Even though 3 years ago we finally got generics, for example, in Go, generics are not quite powerful enough, again, compared with Rust, for example, or Java. So you also need to keep it in mind. And generally, when I started working with it, first I was excited, but the more I worked with this language, the more I started realizing that I'd like to have something more powerful, generally. More powerful generics, for example, more basic data structures, maybe more constructions. I'm okay with Go's way of error handling, for example, and as far as I know, Zig also uses it a similar way. But again, if you look at Rust, for example, the way how it handles errors, I like it much more. There are a few ways in Rust to do this, but for example, that basic way with like propagation errors, yeah, I think with like dot, question mark, that's really fantastic. So ideally that's all you need to do. Not always, but generally yes, it is. So from my own perspective, yeah, the disadvantage, like, the language is too minimalistic itself, but that's also an advantage, so it's a kind of a double-edged sword. And the last issue I see about Go, from my own perspective, is performance. I mean, again, compared with generally all mainstream languages like Java, Node.js, and so on, usually Go wins. Not a shade of a doubt about it. But for example, if you compare it with C, C++, Zig, Rust, you'll definitely see that Go consumes much more memory than such languages. Its binaries are much bigger. Usually for backend it's not a big deal at all, but if you'd like to use Go as a WebAssembly language, probably that's not a very suitable language for this, because you understand, the least binary size I've ever been able to get in Go, it was around of 22, I don't remember exactly, something like this megabyte. And the project wasn't really big, it was just a simple blog generally with quite basic functions. So also need to keep it in mind. For example, Go isn't suitable for WebAssembly, and it's not even about its performance, it's just about its binary size generally. And yes, and because of its performance, because that Go consumes more memory than, again, like for example, such performant languages as C, C++, Rust, and Zig, and other similar on them. It's not really suitable for something really performant, for game engines, for example, for high performant backends, and so on. But as far as I understand their intention, Google has managed to carve out a niche for Go. Actually, its niche, it's quite understandable to write generally usual APIs, for example, usual backends generally, because Go is very simple, works pretty fast, generally faster than Java, or at least comparable, faster than Node.js or Bun. I don't think it really matters here. It consumes less memory than all of them, and yes, one of Go's main features is multi-threading. I can confirm it's quite easy to work with multi-threading code in Go. Quite often, like mostly, I would say, in my experience, you don't even need to think about this. Real typical cases, for example, you have a request to your database, there are a few queries, and if they don't depend on each other, you can simply just wrap each query in a separate Go routine, and eventually just you use async await. So you await for all of your tasks, for all of your Go routines, then merge it. It happens just out of the box, you don't really think even about this, just a few simple constructions and that's it. Very rarely you need to use channels, mostly in my experience just to implement graceful shutdown, or if you'd like to use implement actor system, yes, you'll definitely need channels. But again, so its niche is to write typical high-performant multi-threading APIs. What's also cool about Go, it has one of the best gRPC supports. I mean, if you look at some benchmarks, Go usually is among the leaders. It's actually even faster than Rust, because for Rust, unfortunately, we don't have yet an official support from Google. I mean, we kind of have, but we don't have an official implementation, I mean, of gRPC in Rust. So, or I wouldn't use, for example, gRPC with Rust, but I will definitely use it with Go also, just to keep such a thing in mind. You can also, for example, investigate on your own HTTP benchmarks, where there are a lot of languages, frameworks, they compare with each other. And sure, there is Go, like Rust, there are Java, Node.js, and so on. You can make your own conclusions. We don't have even async await again in Go, so basically, yeah, mostly in real life when you use an HTTP framework, for example, you don't even think about this. So yes, pretty simple. So on the one hand, everyone can start working with Go, learning it almost immediately. Generally it's easy to use, and so on. So for business, I think Go is quite attractive. They trust it more and more, and we can see there are more and more Go projects, there are more and more Go developers, and so on. Plus, also keep in mind that it may be easier for you to find a job in Go than, for example, in Python or Node.js, because there are not so many Go developers yet, so you may still use your chance. So if you, for example, if you doubt about this, also it may shift your opinion. So let's make conclusions. Very simple. There are pros and cons of it. Quite performant, easy to work with multi-threading code. Easy to work with interfaces, actually. Also, I forgotten to mention it, to implement polymorphism, for example. Yes, it's quite easy in Go, except a lack of generic support. I mean, again, there are generics in Go, but they're not really powerful. So yes, from my own perspective as a developer, I wouldn't use in Go now in my own projects. I would prefer Rust, for example, because Rust is more performant, more powerful, consumes less memory, and I don't expect you to agree with me, but in my experience and opinion, it's even faster to develop something in Rust than in Go. Why? Because the language itself is much more powerful. There are many more basic data types, data structures, algorithms like binary search. For example, in Go we don't have it in our standard library. You need to implement it on your own if you'd like to do this. Not a big deal, but again, you see, like, it's also a disadvantage in my opinion. The same with set. Like, yes, it's not a big deal to use map just to emulate set, or even write your own set structure, but again, that's a disadvantage in my opinion. And why I would also choose Rust, except raw performance and memory consumption, like garbage collector, like, yeah, but it's also a part of the performance, so I wouldn't mention it. Yes, by the way, I forgot to mention yet that Go has a garbage collector, so it makes it even easier for developers to use it, compared with Rust, when a lot of developers just give up because of famous or even notorious I think both words are applicable here, borrow checker, give up. But in my opinion, Rust Spain isn't only, learning curve isn't only about borrow checker, it's also about crate system. As to me, like, I don't think I've ever experienced any real issues with borrow checker, but when I needed to adapt its crate system, it was just hell. Man, it was just mess. Yeah, that's also a big Go advantage generally from my perspective, that in Go you simply put folders and files whatever way you want and simply import. Pretty simple. The same, by the way, about like packages manager. In Go I've never had any issues with it. Like, it just works pretty fast, pretty expected. And by the way, also one big more advantage of Go I should mention is compilation time. It's usually almost instant, so you kind of feel like you're working with an interpreted language like Python, for example, in my own opinion and experience. So you definitely don't even feel that you're using a compiled language. And like, compilation itself in Go is definitely much faster than in Python. I mean, when you first launch your project. So again, it's definitely a win-win situation for Go. In Rust, there is definitely a much more longer compilation time. It's actually worst compilation time among all known me languages. I mean, for example, in C, C++, and Zig, compilation time is definitely faster. I mean, when you first time compile your project. But in Zig, I've heard that incremental compilation isn't really good, but at least when the first time you compile your project, Zig has an advantage here. So Rust definitely loses here, unfortunately. I hope it will be improved in the future, but right now, if you're working with Rust, you need to keep it in mind. You need to understand that your first compilation may be really long. Incremental compilation, this is actually why we need all of our quite elaborate, intricate, fancy crate system that you can, for example, modify only 1 or 2 crates, and your Rust project will rebuild only them. It won't rebuild everything from scratch, so that's definitely a huge win. This is one of the reasons why we should generally structure our project this way. It's one of the reasons. The other reason is definitely like clear responsibilities, boundaries, and so on. But yes, it's my point of view. And also I need to add that WebAssembly, Rust is definitely cool. I think this is the best languages right now. This is just the best language right now for WebAssembly. Why? Because of its binary size. It's not, again, the smallest binary size. I think C, C++, and Zig has even a less binary size. But Rust has a lot of features they don't have. It's safe. It's really easy to use. I mean, for example, HTTP frameworks, they're really cool, and they are among the fastest according to a lot of benchmarks, tests, and so on. So in my experience, it's even easier to use, for example, Ectix, not sure on pronunciation, so please fix me, or Exum, for example, Salvo, whatever. It's much easier to use, a more pleasant way, more pleasant experience to work with them, compared again with, for example, GOS frameworks like Gene, Fiber, Echo. But Fiber actually I like much more than Rust, than Fiber, than Gene, for example, or Echo. But yes, anyway. So Rust is blazingly fast. Its binaries are really small, around like your project, like maybe 1-2 megabytes, even less, for example. Yes, so WebAssembly, it's critical, because anyway WebAssembly is inevitably larger than for example, initial JavaScript files that JavaScript frameworks such as Svelte or Solid or React, for example, create for you. So yes, Rust is definitely cool. For WebAssembly, it's safe, has strong safe concurrency guarantees that it just should work. So with Rust, you may spend a little bit more time debugging code, like working with code, but when it works, it just works. So like ideally, you'll never run into runtime errors. Because in Go, for example, if you simply forget to check if it's nil or not, your application simply crashes. So definitely not good for production. We're all humans, we all make mistakes, so you simply may forget to check such a case. It's always happened to me, like it may happen to anyone. And Rust won't actually let you just do this. I mean, sure, if you use some tricky, intricate, unsafe code, raw pointers and whatever, yeah, you may run into such issues, but I don't think that most of developers will ever need this. And again, even with unsafe code, Rust has a lot of checks. Borrow checker still works. So anyway, it may analyze and locate your errors and highlight them. So yes, so in a nutshell, performance, memory, safety, concurrency, WebAssembly, and so on. This is the best language, in my opinion, right now ever for such things. Sure, its ecosystem in some areas like game development, for example, is much less than for C++, but I'm talking now mostly about backend server development, generally web development. It's not like we can't use Rust for game development, we can, but there hasn't been yet any efforts where like nobody has ever tried, I think, to create something like Unreal Engine, Unity and so on for us, but we'll see. But it's a separate topic. Yeah, so like, yes, I think I voiced more or less all of my ideas about Rust. It's much more pleasant to work with it. Generally, its binary size is much less, so we can definitely use it for WebAssembly. Development speed is faster, pleasure is bigger when I work with Rust than with Go. Performance is much faster. It consumes less memory. A lot of advantages here, isn't it? The only disadvantage, in my opinion, is the learning curve. This is definitely like harder than for Go, and yes, not everyone can overcome it, can overcome themselves for this, so keep it in mind. And for business, I think generally only if they really do need Rust, they have no other option, but generally I think Go will be much more spread than Rust, at least in in backend development generally, because on the one hand, like it's easier and cheaper to hire Go developers than Rust ones, and Go is more than enough for a lot of cases. I still stick to my point of view about performance. The more performant your project is, the less cloud computations you need, the more you can save money on like cloud maintenance generally for your servers, and so on. The better user experience you can provide, because your project will be inevitably faster. Sure, it's also a matter of your optimizations. Generally, you can write not optimized Rust code as well, not a big deal. But I mean, my point is that when you use Rust and all of its ecosystem, anyway, it will be much faster than Go, inevitably faster generally, and it will consume much less memory. But for business, yeah, Go feels much safer, I think, cheaper, and more than enough for their needs. I think they're totally fine to pay more money for clouds generally, for servers and so on. Then it overweights their risks, because as far as I understand it, from a business perspective, they are okay to pay more if they can reduce their risks. So as to me, as for a professional developer, Rust is much more attractive, feels better, like I develop faster with Rust, better speed, less memory, can use it for WebAssembly and so on. But for business, I think it's quite the opposite. And what about Rust itself? I've already told a lot about Rust, but again, just the only real disadvantage compared with Go, in my opinion, is the learning curve. Not everyone can master it, I agree. Rust sometimes is more verbose generally. Sometimes I disagree with its syntax. Sometimes I prefer like Go's way to do this, because for example, in Go, when we have a function and arguments inside, we just write, for example, a variable name, tab, and a type. Yes, in Rust we just write like a variable name, oh my goodness, that double comma, like double dot, forgot, but you got what I mean. Yeah, and then a type. Not a big deal, but still, Go feels better this way. There are a lot of such examples in syntax where I think Go is better, but sometimes Rust definitely feels better, as I've already given you an example with error handling. Yes. So yes, generally Rust syntax may be a little bit more verbose, but it's not a disadvantage. In my opinion, it's even it's more about an advantage than about the disadvantage. Why? Because you remember when you started working with Go, after your, for example, Node.js, like Python and so on. Go itself is usually much more verbose than them. It's a more low-level language generally itself, more verbose, but everything is crystal clear. You don't have iterators, you don't have anything like this. Everything, yeah, like is a kind of low-level way, but this is why it's so easy to read Go code and understand everything. And by the way, yes, I forgotten to mention, also the biggest, in my opinion, disadvantage of one of the generally the best advantage of Go, that when you when you come to a new project, it's quite easy to delve into this and start working on delving, like doing your tasks. Because I can confess, I've never been successful in understanding Python projects, even not big ones. Like to me, it's always been just hell. So yeah, this is actually really a great advantage of Go. And Rust, on the one hand, Rust itself is even better. It's more verbose, more explicit. For example, you need to explicitly mark your functions as async, more code for generics, more code for interfaces in Rust. We call them traits, and there are some differences between them. They're more powerful and flexible than in Go. And but Rust itself is much more powerful. Has, for example, iterators like map, for example, function, filter, and so on. And this is why it's very, it's like, to put it like, it really depends on the programmer's level much more than Go. Because in Go, like any programmer can write code, and when you come, you'll most probably will understand it. In Rust, maybe harder in some cases, because there are many more features like syntax sugar and so on. But on the other hand, the language itself is more verbose and so on. So from that perspective, I think it's Rust is more explicit, and depending on the situation, sure, but it may be even easier to understand Rust than Go. But again, Rust, is definitely, Rust depends on the programmer's level much more than Go. And this is, I think, also is a huge concern for business, why they may prefer Go over Rust unless they can't solve their project's needs with Go, generally. Yes, like error handling I've already mentioned. Yes, Rust itself has a much richer standard libraries than Go. A lot of basic data types, for example, set, queue, for example, or stack, I think it also has, if I remember it right. Binary tree, even like 2 or 3 types of binary trees as far as I remember. Go doesn't have all of it. Yeah, sure, you can implement it on your own, but it's an additional time. You need to spend on it additional efforts, additional money, and most probably it won't be so effective than like in Rust, for example, because it's been optimized by Rust core team, like battle proven and so on. So also keep it in mind that Go, in my opinion, doesn't have enough of basic structures. It will be cool to have also like binary tree, for example, and so on, but it's just, yes, just it is as it is. Just need to know and understand it. Rust provides many more things out of the box, except surprisingly async runtime. because yeah, this is when I figured it out, I was kind of perplexed. But yes, Rust doesn't have itself in its standard library async runtime. You can use, for example, either async standard library or something like this, but it's not a standard library. It's an additional crate you need to install, or Tokyo, the most like battle proven, the most performant, I assume, and generally the most common crate. Not a big deal to install it, but yes, but again, just need to know, need to understand such a feature of Rust that like I think almost any web backend project will inevitably start with Tokyo. This is the first library you need to install. What I also like about Rust that it's zero cost abstractions. It's not just marketing, it really works. I can give you, for example, one example. Even to like generally when you use all of its syntax sugar, iterators, like map, filter, and so on, under the hood it compiles into more or less the same machine code that, like, if you just like compare it with if you, for example, just wrote it manually, all of those for loops, checks, and so on. Also, what I like, if you need to use, for example, if you need to implement polymorphism and you need to use traits, I mean interfaces in Go. In Go, there is no way to avoid overhead because interfaces are inevitably slower than direct function call. I'm not gonna delve into this right now. This video is already too long, much longer than I initially was planned it to be. And but in Rust, for example, you can use a combination of traits with generics, and you eventually may have zero overhead, like it will be the same way if you just called a function. So if you don't need to have runtime like checks, maybe not even just checks, I mean when you decide in runtime, for example, what database to use and so on, if you can use it in compile time, so it definitely, yes, with generics and traits you can achieve it. In Go you can kinda achieve something like this, but according to my benchmarks, I'm gonna reveal it in the future, that generics in Go are quite slower. They are slower than a direct function call, and they're even slower than interfaces itself, so just for you to understand. In a nutshell, in Go, when we use interfaces, we inevitably have an overhead because of virtual tables, indirections, and so on. But in Rust, trait interface doesn't inevitably mean that you use virtual tables and so on. It's up to you. If you use dynamic trait, in this case, yes, but if you just use a trait itself or with a combination with generics, you have zero overhead. Sounds fantastic? Yes, it is. So to summarize, like, it's a much more powerful language itself, much more performant, much more safer, more features, faster to develop projects, in my opinion, since you've mastered it. The only real big concern is, yes, the learning curve. Just you need to keep it in mind. For business, I think Rust nowadays is much less attractive unless there are some needs that only Rust or C, C++, Zig can provide with. So in this case, they don't have a lot of choice, and most probably they will use Rust, at least in backend development, generally in web development. Go definitely feels safer, better for business, cheaper, more reliable, and so on. But the most important thing about all of it, and this is actually much more important than everything I've just told, that the most important is what you really do like, what you sincerely like. Even if objectively, for example, one language is better generally than the other, if you like this language, you will be much more successful, much more productive. You'll be a much better developer generally, because you'll get fun with it, you'll have a lot of pleasure, you'll be satisfied, rather than like, I'm using this language and I hate it, but it's better. Guys, don't do it. Don't do it this way. So the most important, I mean, for you as for developers, if you like Go, like generally go out, continue with Go. If you like Rust, or at least would like to try to do something with Rust, do with this. So again, it's more about your personal preferences than about like how it generally works objectively. So sure, there are such things like game development, for example, generally performance critical things, and WebAssembly where Go isn't really suitable. But again, if we're about backend server development generally, so on, like generally you can always choose Go over Rust and you won't lose. Just do what you like, enjoy what you do, and you'll be successful. Yeah. Phew, it was sweaty. It's almost 40 minutes. I hope it was interesting. Yeah, this is a new such a format, kind of philosophy conversations, like discussions, when like I'm sharing my point of view with you, when I'm trying to look at this from a business perspective, and so on. So as for me, generally, initially I started working with Go, then I started learning Rust. Finally I dared, and I immediately felt in love with this language. So my ideas, thoughts, feelings about Rust had been right. So this is also actually maybe very useful and suitable for you. The most important thing is just believe, trust yourself. If you feel that this language is good, better for you, just do this, just try to create something, and not just something abstract for education purposes only. Try to create something real, something that may bring some use, that can help other people, like can help you, for example, yes, to earn money, to achieve something, to help other people, to solve their needs, to solve their pain, and so on. Yes, and performance itself is not just about the languages only, it's also about the tools, because as I've already mentioned, gRPC with in Rust is slower now, surprisingly slower than in Go. So just also keep it in mind. So yes, just trust yourself, follow the flow, use the language, the tools you really do like, and yes, because a happy developer who are passionate like about their language, tools, frameworks, and so will inevitably be better and more successful than someone who uses kind of the best tools, languages ever, but who doesn't really like it and just use it because it's they feel they're kind of compelled. Don't do this. Yes. Bye.